Good day everyone, welcome to Learners Hub. This is a channel where you learn about construction related knowledge, where construction problems and knowledge are demystified. If this is your first time encountering our channel, please subscribe and hit the notification bell. What this will do is that anytime we drop a new video, you will be one of the first set of people to be prompted and you can watch and learn from it. Now, a while ago we began a process of teaching ourselves on estimation, where we are using a live project that is under construction for our estimation. We began. Before we proceed into today's video, let's do a quick recap on what we have learned so far. A while ago we have done our previous video where we explained the process of estimation and what estimation is. Check the description panel below. You will see the link into the video for the previous videos that we have done regarding the process of estimation, where we explained that you will need to generate an item list for every drawing that you are going to use. That your item list will serve as a guide for you to guide you through your estimation. Now we proceeded by estimating the site clearing, setting out materials, and presently we are on excavation. We have done a part 1 of our video on excavation. Today's video will be centered on the part 2 of our video on excavation. So in our previous video, which is our excavation part 1, we went through the procedure of calculating the girth, and for as a means of summary, let me just do a quick recap on that. The process of estimation for excavation involves the following. 1. From your live drawing, you generate a foundation layout, because the drawing you are dealing with actually is a bungalow. But if you are dealing with a story building or a multi-story building, you are going to be provided with a structural drawing that shows the foundation layout already. But because this is a bungalow, most times, because a bungalow does not require any special type of foundation, it doesn't come with a structural drawing. You'll have to be the one to generate your foundation layout. For you to generate your foundation layout, you need to pick the line along the center line of every block work member you have there, because it is along that point that you're going to be having your excavation. And that same line that you have picked along that center line cumulatively will form the girth of the excavation. And that girth now is the I explained that it is the total linear meter along which excavation will be done. It is also the total linear meter along which your block work will be done. It is also the total linear meter along which your foundation concrete will be done. Now, that being said, we estimated our girth in our previous video, in the part 1 of this video. The value we got was 76.45. We got a value of our girth. Our girth was 76. .45 meter. This was the girth that we calculated, and this girth that we have calculated serves as the cumulative linear meter along which excavation will be done. Now we need to bear in mind that this value, we need to keep it in mind, because we are going to be needing it for a lot of things to be done with those we are going to be needing it for a lot of things in estimating other items we have on this list here. Now, for us to proceed with this stage of our estimation, that we need, if you check from this list that we have here, excavation that we're excavating, the unit of measurement is meter cube. That means that we need 3 dimensions for us to be able to estimate this excavation. 3 dimensions is needed. Now, one of the dimensions has been calculated as 76.4, which this will serve as our length, the total length of excavation. So our girth will serve as our total length. Now we need two other dimensions, being the width of excavation and the depth of excavation. Now for us to be able to get this, most times when drawing comes like this, you can see this line that they write S04. That line is actually a line showing the section that is cut along this building. Let's go and check if the section provided shows us a detail of the foundation. So we need to move into the section of this drawing. Now we are in the section of the drawing. The section cut actually did not show so much of the foundation. If we see, it does not show so much of the foundation layer. It only shows us the thickness of the foundation concrete. It shows us the feeling that we have an hardcore. We have a hardcore feeling. We have a compacted lateritic feeling, that is the soil for infill. When we get there, we'll talk about estimation. But it indicated that what you are seeing here are block works. They are block works. So if these are block works and this is our foundation level, these are our foundation level, and look at this line you see here. This line you see here, that this thing is overhanging on from here to here. That is our natural ground level. This yellow line that you are seeing here, this yellow line is our natural ground level. Now if you see that these are oversized concrete, above this natural ground level is 450 mm. Let us bear that in mind. Above this our natural ground level is 450 mm. Now if you had watched my previous video on this excavation, I mentioned that a bungalow usually is sitting on a strip foundation, where I said strip foundation is a continuous strip of concrete, that continuous mass of concrete that has its width as 3 times the thickness of the wall sitting on it, and its depth will be thickness of the wall. Now from that, since that is not provided, with that definition in mind, we can create a section for that foundation. Now for us to create a section for the foundation, we'll be having something like this as our section. No, sorry, don't mind me. So we'll be having something like this. Now this will form our natural ground level, NGL, natural ground level, and these are hardcore feeling. Now here is a continuous mass of concrete. This is a continuous mass of concrete whose width will be equals to this our wall here. From the drawing that we have, from this drawing that I have, the wall we have is what? 225 block wall. 225 block wall. So we can confidently come here and say that the thickness of this wall here, is 225. Now if our wall is 225, remember I said in my definition that the width of the strip foundation is 3 times the thickness of the block wall. So if our block wall is 225, then definitely our the width of our foundation will be 3 multiplied by 225. Using our calculator, we have 225 multiplied by 3, that gives us 675. So if we have 675, meaning that this is giving us 675. Now that is sorted, and we said the thickness will be equal to the thickness of the wall. If this wall here is 225, then the thickness of this concrete also will be 225. Now from this, if you see that the concrete is spanning this line you are seeing here now, this line that my mouse is hovering on now, is our excavated point, and this is our concrete, foundation concrete, sitting on it. Now the foundation concrete is also taking the width of this excavation. This line you are seeing here is our line of excavation, meaning that from this point to this point is the width of our excavation, and also our concrete is beginning from that point and is stopping from that point in terms of width. So the width of our concrete is also taking the width of the excavation. So if this line you are seeing here is our excavated portion, that is the excavated portion, it therefore means that the width of the concrete is the width of the excavation. Therefore our width of excavation will be equal to 675 mm. Now we've gotten the second dimension that we need, which is 675. 675. Sorry. 675 mm. Now we are left with the depth. Let's go back into our section. Let's go back into our sectional drawing. Now from here, from the drawing that we have, the depth of the foundation above natural ground level is 450. If you remember, I said that we should keep that in mind when I show us the drawing. We'll go back into it now for us to be able to. It's 450. So let's go back into that drawing and confirm. Now this is our natural ground level. The height, this is our foundation height. This is our foundation height. Above this natural ground level is 450 millimeter. So now, which is what we have here, 450 millimeter. Now if the total depth, by rule of thumb, the total height of foundation, when I say by rule of thumb, that is by from experience, the total height of the foundation is usually 1 meter. It's usually 1 meter. So if we have 1 meter as the total foundation height, and our foundation is higher above the natural ground level by 450 mm, that means we are going to deduct 450 from 1 meter. So if you deduct 450 from 1 meter, what you are going to have left here is going to be 550. millimeter. Now if our foundation is 450 higher than the natural ground level and the total foundation height is 1 meter, if we deduct 450 from 1 meter, we are going to have 550. That means that our depth of excavation beginning from here, from our natural ground level to this bottom here, is 550. So the depth of our excavation now will be 550. So we see depth is equals to 550. So now we have our third dimension. So we can go into there and say our third dimension, being the depth, is 550 millimeter. Now if you recall, I mentioned at the beginning of this video that we need three dimensions to estimate our excavation, and I pull up this list by showing us that excavation on this list is a meter cube. So meaning that we need three dimensions, and the three dimensions being the length of excavation, the width of excavation, and the depth of excavation. Now going by what we have here, I said our girth being 76.45 meters will be the length of our excavation, because that is the overall linear meter along which the excavation is going to be done. Now we went further into this section that we have here to calculate the width of our excavation, and from the definition we give, we said a strip foundation is a foundation type that is 3 times the width of the wall sitting on it, and the thickness will be equal to the thickness of the block work it is supporting. So I pull up the drawing by showing us the thickness of the block work that we have, and the thickness of our block work, this is foundation block work, is 225. So if our foundation block work is 225, then it means that the width of our foundation concrete, that is strip foundation, will be 675. That is 3 times the thickness. Then the thickness of the concrete will be 225. So that being said, I said this line you have here, this line like a U that you have here, that is housing the foundation concrete, that house there is our excavation line. It's our excavation depth rather. Now, and if you check from this point here to this point here is the width of your concrete. That means that the concrete is taking the entire width of your excavation. So meaning that the width of the concrete is equal to the width of excavation. Therefore, we said W, being the width of our concrete, is also the width of excavation, is 675. Now we said from experience the foundation height is always total height, that is the height from this point, because this one you have here is your oversight concrete. This is your oversight concrete. A layman in Nigeria will refer to it as German floor. This is your oversight concrete. Now from this point here to this base here is the height of the foundation, and that total height is defined as 1 meter. But from our drawing, this DPC, this foundation oversight concrete, is higher than the natural ground level by 450. Now by mathematical expression, you can say that 1 meter minus 450 will give you the depression that you have here, the depth of excavation, meaning that 1 meter minus 450 will give us 550, and our 550 is beginning from this point and stopping at the base of your concrete. So that is the depth of our excavation, and we calculated that as D. Now that we have the 3 dimensions, we can now go further and calculate our excavation. So we can now say excavation is equals to 76.45 multiplied by, now these 2 values are in millimeters, we need to convert them to meter, so that you have, because if you want to calculate for anything at all, you must make sure they are all in the same unit. One cannot be in meter and the other will be in millimeter. The value you will be getting will be a wrong value. So the most ideal thing is to take those ones in millimeter and take them back to meter, so that it will conform with what we have on our list, being that we are having a meter cube, that is meaning that everything is meter. So converting this now to meter means that you divide each of these by 1000. So if you divide 675 by 1000, that gives you 0.675. So the width of excavation now will be 0.675 multiplied by the depth. You divide the depth also by 1000 millimeters. That makes this 0.55 in meters. Now our depth also will be 0. Don't mind me. So 0.55. Now if we pull up our calculator, we see from here, if we pull up our calculator, we say that 76.4545 multiplied by 0.675 multiplied by 0.55, that gives us 28.38 meter cube. 0.38 meter cube. And that is our volume of excavation. So this is the total volume we are going to be excavating for this drawing. For this drawing that we have here, the total volume of excavation now has been estimated as 28.38 meter cube. Now thank you for watching this, and in our next video we'll be talking about the next item on our list, being the leveling and compaction. We'll be talking about that in our next video. If you are still with us till this time that you are watching video, it means that we have learned one or two things from our video. So kindly give us a like button and kindly subscribe to our video to ensure that this video gets a wide is widely spread, so that a lot of people can learn from it. Thank you very much. We'll look forward to seeing you in our next video. Goodbye.